Hello YouTube, this is Jesse from STEM APKs. Welcome to another tutorial. In this tutorial, I'm very excited because we're going to be starting to where we left off in the last tutorial. And as you remember, in the last tutorial, we started to get the ground ready in order to use modern OpenGL, and we're going to start doing that. What I want to do in this tutorial, what I want to get accomplished is I want to show you how to separate shaders into their own specific particular programs, how to keep the main implementation C++ file clean, and how to also be able to include some other helper files that will help you in the creation of shaders. And then I want to test the application with some cool application using OpenGL. So that's what we want to get done. So stop talking. Let's get started. The first thing I want to do is show you the code from last week, from the last tutorial. So it was tutorial 1, and this is what it looked like. And as you remember, I mentioned to you that this is where the shaders are created. That's the vertex shader being created, and this is where the fragment shader is being created. And everything else is pretty much will stay in the implementation file. So I'm going to show you this new code that we have using um, the new implementation file. As you can see, it's basically the same. This is basically the same, but as you can see here you can see that this is where they're creating the vector vertex shader and the fragment shader. And as you can see, they're assigning these names: triangle.v, GLSL, using the shading language. That's actually what this is. It's just looks like C, but it's not C. But it's a C. It's a C as it gets. So we don't call it C, but it's basically C. So that's what this is, these two lines are doing. And here, as you can see, program and all that, you see it here, and it's the same, stays more or less the same. So nothing changes here, nothing changes here, uh, very little, okay? And so what they're doing is they're taking these and they're putting it into a file. And I'll show you how to do that. And if we look at my tree structure, in my program, you're going to see that I have the implementation file. I have the vector GLSL, the vertex shader using shading language. That's what that extension means, GL shading language. And then the fragment shader. And I also have a directory here that I got from the Kronos website. There are helper files that will help you to create these guys. So I don't want to get into those. All you need to remember there, and let's look at them. There are helper files that will make your life easier. One of them is called shader util C++, and don't worry about it if you do not understand. All it is doing is loading, is finding, loading, and creating shaders. It's basically helper files to make your life easier. All you need to do, you don't need to get into that right now. It's just making your life easier. And this one is the header file. And as you can see, it's just reading a file, loading a file, print the log, keeping everything together, and then creating the shader. Okay, nothing that you haven't seen before. So don't worry about that yet. And that's what's happening in that directory there. Is here. And if you did not have time to copy that, don't worry about it. You can go to my GitHub page and I have everything ready for you, making your life a lot easier so you can follow the tutorial without having to stop every minute to try to copy. So basically, what is in those files? What is in the Vertex Shader file? What is in here? And what is in here? Let's find out. So, like I said in my last tutorial, everything that is in that Vertex Shader is this right here from the last tutorial. So whether if you don't believe me and you want to check what is there, you go triangle, vector, GLSL, and you can see that is attribute vec2 coordinates 2D void main void and GL position vector 4 coordinates 2D and 0, 0.0, 1.0. It's the exact same thing that you see here. Okay, and that's exactly what is going on. Also, if you look at the fragment shader, of course, it's not going to be the same because this is from this tutorial and this was from last tutorial, so they do not match. But it's basically, as you can see, the same thing. Void main void and then GL frag color, and it's the red, the green, and the blue. 012 RGB. And here 0123 is red, green, blue, and the alpha transparency. And that's what we're going to be playing with in this tutorial. So basically, like I said, those are the files. So you have your implementation file, and so you can keep track of these. I know it can get confusing. That's why I'm breaking it down. This is your C main file, your implementation file, and as you can see, let's go a little bit over it. This is your triangle being created. As you can see, these are on the positive coordinates. This one is in the negative quadrant for the x and the y, and this one is on the negative on the y quadrant. So if you remember your Cartesian coordinates, you're going to, let's say that you have, let's say that's your Cartesian coordinates. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So let's say that your 0.8 will be more or less 0, x, and on the y, so it'll be right there, more or less. So that's where your first point is. And then negative 0.8, then negative 0.8, let's say will be negative 8 and negative 8. Uh, so that's the x, and then the y, let's say it'll be here. And then positive and negative. So positive on the x, but negative on the y. So it'll be right here. And then you draw the triangle. I'm sorry, I'm really sloppy, but it's just to get the idea going. And that's what's happening. So this is your first coordinate, second coordinate, so it's 1, 2, and then your third coordinate. Okay, that's all is happening. Nothing that you haven't seen before. So this is what's happening here. Okay. So now, if we continue going down, don't worry about this. We'll talk about this later. Um, don't worry about it for now. But basically, what's happening here, these are created, the program is being created, the vertex shader is being attached, the fragment shader is being attached. Now they're being linked in a program called program. And they're checking to make sure that if the linking went all right, and then it's returning 0. So here, if we keep going down, And like I said, it might take a couple times for you to make sense of what's going on, but nothing major is really going on. And like I said, they created these in order to give more flexibility for the to the developer, and I'll show you why and how. So here, these are the buffers. These will become second nature to you after you use it a few times. Swapping the buffers, as you know, you may not know in OpenGL, you're using two double buffers. So one is doing one thing while the other one is being displayed, and we'll talk about that later. And then just want to show you the main function. You initializing the context, the display mode. You're using GLUT RGBA with alpha. You're using alpha double buffer and the GLUT depth. And then the window size, very important. Remember these numbers because they're gonna come back. They're 600 by 500. So 600 pixels in the X and 500 pixels in the Y. And then just checking for errors and making sure that your versions are correct. So that's basically it. So now let's run it. So let's run it by using G++. Actually, let's be lazy. And it's in my history. And if I find it, it's there somewhere. By this time, I would have wrote it already. That's what happens when you're lazy. And there it is. So you're using name of the file, name of the executable, libraries used, da. You've seen these a few times now. So you hit enter, clean compilation, look for the executable, and now you see it right there. And that's the triangle. And what are these lines here? Well, these lines are transparent lines. They're that every 100 pixels is uh, is producing a line on the Y. On the X, it stays the same, but it goes up on the Y axis, as you can see. So it's every 100 pixels. So if you want to check what's going on, let's look at the code. So the easiest thing is to look at the code, and let's go and find out the fragment shader, because that's where the colors are being created. So you will go to nano triangle, F for fragment, and there it is. So it's a combination, as you can see, of blue and green. So it's not a true blue. So if you want to make it a true blue color, here you will change it now. Let's change it so you know what I'm talking about. 0. And let's make this one 0. And let's just make it solid blue. And here is telling you that don't worry about that right now. Just remember that on the X, every 100 pixels. And we'll explain that later. So let's close this for now and run it again. Well, compile it first. Now we run it, and there is a solid blue. Excuse me. In every 100 pixels. And as you remember, I told you to remember 600 on the X and 500 on the Y. And let's say if it's true or not. So that's 100 pixels, 200 pixels, 300 pixels, 400 pixels, 500 pixels, and then 600 pixels. And that's so it's from here to here, there's 100 pixels. So it's 100 pixels, and then 200 and 300, 400, 500, and 600. And now let's check on the Y. So if we want to check on the Y, all we need to do is change the fragment shader. So we'll do that again. And now instead of the X, let's check how many pixels on that triangle on the Y. So all you need to do is every 100 pixels on the Y. That's all you're doing. So let's do this one now. Compile it again. And now run it. And there it is. Now, instead of the X increasing, it's the Y increasing. So let's do the same thing again. So if we go and we check that is from here to here, it's 100 pixels, 200 pixels, 300 pixels, 400 pixels, 500 pixels, and then 600 pixels. So it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And I made it a little bit bigger, extending it, so that's why it's a little bit uh, larger. So let's run it again. Let me close it again, because I was saying, why is it so big? So let's do it again, and this time I'm not going to. So let's do it, and there you go. You go, it's 100 pixels, 200 pixels, 300 pixels, 400 pixels. So it's 1, 2, 3, 4, 500. So it's exactly 500 pixels. So it's 6 on the X and 5 in the Y. So it's 1, 2, 3, 4, and 5. And that's the end of this tutorial. If you like this tutorial, please click on the like box and subscribe to my channel. And in the next tutorial, we're going to be continuing to do some cool stuff using OpenGL and integrating with other libraries. Thanks for watching and have a great day.